Hi, this is Jason. I just wanted to create a little video to demonstrate blockchain and the key concepts of blockchain. So I've written a Python script. Now in this script we have, I'm passing in the last block in the blockchain. So this was block 5. There's a transaction in there, so some details of a transaction. This is the previous hash. And the sequence number for that previous hash. And this is the new hash that came out for that block. So what happens is that when I need to create a new block, just say you've got new transactions that you need to add because the blockchain keeps incrementing with more transactions, and more transactions just keep on getting added to the block. This is a really simple example. So in this example, we've got the previous block was 5. This is your, as I said, this is the details of what you want to store in the block, the text. Previous block, and that's the hash of it. I'm going to put some transaction information in here, just going to make some stuff up. So put any number we like. From and to date, of course, they can be very long. So there's a real transaction would be, have a lot more information in it than that. This is just for a test. So what I'm going to do now is run the code. What's going to happen is, first of all, it needs to validate the last block. So the code is going to validate that the last block is in fact correct. It's going to validate the hash. It'll recalculate the hash. If there's any problem with that hash, then it will then output that the last block had an invalid hash. If the last block is correct, then it'll create a new block. So by executing this code, then we'll just quickly run this through. Okay, so as you can see, it verified the last block. So this was the last block in the blockchain. And that was verified as correct. Then what it did is it went to create the new block. The new block has the transactions for the new block. We needed to go through and call this function, validate last block. What this does, sorry, that already has happened. We create new block. So we're passing in the last block hash, the transaction text. What it then does is it works out what is the next length of the chain. So where are we at in the blockchain, and what is the increment in the blockchain. So basically adding 1 to the increment. Then what we need to do is we need to come up with a hash that matches the proof of work. Now, the proof of work is something that needs to be calculated in order to come up with, to meet the proof of work criteria, which is like a secret function within a blockchain to make sure that the next block that gets added meets the criteria of that block. For this little simple test, what we are doing is we're going to make sure that for the new hash must start with a 0 for the first character, and the second character of the hash needs to be some digit, so some digit 0 to 9. Of course, the proof of secret is going to be a lot more complicated than that, but this gives you a good idea of what we're talking about in a proof of secret. So what it did is then it iterated through the serial numbers, kept on incrementing the serial number and recreating the hash until it came up with a hash that matched the proof of work. As you can see here, it went through 11 attempts, kept on incrementing the serial number until it came up with a new hash which satisfied the criteria. So as you can see, previous hashes here didn't satisfy the criteria. So the criteria is that the hash needs to start with a 0, and the next number, so the next character needs to be a digit number from 0 to 9. So after 11 attempts, we've actually come up with a valid hash of that block, and that would be added to the end of the blockchain, and that would then be block number 6. So this demonstrates really, how blockchain works. In reality, it's a lot more complicated. The block is very big. If you're talking about cryptocurrency, these blocks become very massive. And you've got miners constantly looking to add the next block to the blockchain, and they actually earn money for that. But this helps to demonstrate the concept. So, yeah, hope you enjoyed my video.